So this is also going on page 27 when we are done. Right? So we are solving nonlinear inequalities. You have solved linear inequalities before, so let's talk about what a linear inequality is. If I had like 2x plus 3 is greater than 5, I don't know, something like that. That looks like a 7. Greater than 5. Greater than 5. Then I would have 2x is greater than 2, right? Then I'd divide and I'd get that x is greater than 1. And then on my little number line, I'd have a 1 right here and then shade that way, right? We agree with that? And you all have done that. It's kind of an old business type of thing. So, oh, hang on a second. Let me get her something. So that's linear inequalities, old business, right? So what we're going to do is going to look a little bit different than that. I just wanted to make sure you know that that's a linear inequality. We're going to look at nonlinear inequalities, but just for polynomials right now, because there's other nonlinear inequalities, but we're not there yet. And here's your steps of what to do. And I'll explain these a little bit better as we get to the actual steps. But the first thing is to solve the function for 0. And it's not really an equation because it's inequalities, but we still got to get 0 on one side there. Then we're going to create a sign chart. This is probably something that you've never done before, but we're going to do it a lot. We do it with polynomials. We do it with rationals. We do, it continues on in calculus for a long, long time. Sign charts are about to become a big part of your life. And then we're going to test values in each interval to see if the values in the interval are positive or negative, right? And that's all we care about. So if I said, we're going to multiply negative 17 times negative 583. What's something you can tell me about the answer? Negative 17 times negative 583. It's positive, right? I don't care about the actual number. I care about if it's negative or positive. Does that make sense? So it doesn't even matter. Even if we're multiplying easy numbers, we don't care. All right, so then we're going to interpret it to get to answer the inequality. And be sure to write your answer in interval notation and think about the endpoints. Okay, so interval notation, none of this inequality mess that y'all are going to have alligator mouths backwards and upside down and who knows what. All right, so let's look at one of these and let me tell you what all those steps actually mean here. So we're going to solve this inequality. We do have 0 on one side. If not, we would have to fix that somehow. I also need it factored all the way. This is completely factored for me, so I don't have to factor anymore. And then I'm going to make a number line, okay? And I don't care about like making the number line where the numbers are spaced evenly so it makes sense like a ruler. I'm going to space them out evenly whether the numbers make sense or not. I have 3 zeros, so I'm going to basically space them out evenly so that I have room to do stuff. I don't care if the spacing doesn't make sense for accuracy. That doesn't matter at all, as long as I have them on there in the correct order from least to greatest. So the smallest 0 here would come from that. That'd be a negative 4. Then this 0 would be negative 1, and this one would be 3. Okay, so I'm just putting those on my number line. Don't care if accuracy-wise they're spread out evenly. Then this here, saying my function is greater than 0, that means I'm looking for when it is positive, right? Positive, but not 0, because I don't have that line underneath it, which means that these zeros have open circles on them. If I do that now, it's going to help me make sense of everything when I'm done. Now, here's where I start to test values. All I care about is whether or not my function, when it's not at 0, if it's above or below the x-axis, is it positive or is it negative? So I'm going to pick something to the left of negative 4, something between negative 4 and negative infinity. Could I pick negative 5,800,000? Yes, but we're not going to do that. Let's pick negative 5, okay? So we're going to pick negative 5. When I put negative 5 in here, negative 5 minus 3, is that positive or negative? Negative. Negative. I don't even care what the number is. Negative 5 plus 1 is also negative. Negative 5 plus 4, negative. That makes sense? So I have 3 negative numbers that I'm going to multiply together. Don't care what the actual number is. I only care about whether it's positive or negative. What would it be? Negative. Negative times negative times negative, that is negative overall. Okay, that makes sense? Then I'm going to pick something between negative 4 and negative 1. Let's go with negative 2. I could have done -3. I could do -2.5, which is sometimes what we have to do depending on the numbers, but if I don't have to get fancy, I'm not getting fancy. So -2. -2 minus 3, negative. -2 plus 1, negative. -2 plus 4, positive. So overall, that is positive. Negative times negative is positive, times positive, it stays positive. Okay, we good? Easy enough? All right, so now between -1 and 3, I can pick 0. And if I can pick 0, I want to pick 0 because that makes everything easier. So this is going to give me a negative and then positive, positive, since it's 0, which means overall it's negative. Negative times a positive stays negative. Then I'll pick 4 because it's on the other side of 3. Don't forget about the ends over here. So 4 minus 3 is positive, plus 1 is positive, positive. Now, if you look at what happens with these signs, they're alternating. It doesn't always alternate like that, because if it did, we just talk about let's do the first one, then they just alternate. So they don't always alternate. After we do these a few times, you'll start to recognize when they will and when they won't, but we're not going to figure that. We're not going to really get into that today because it'll just be too much. Now, let's look at what we're actually trying to solve. I want this to be positive. My function is positive here and here. And since I already put my open circles there, my answer is pretty much written for me. I'm going from -4 to -1, and I know that it's open because they're open circles. And then I'm going from 3 to infinity, and they're open as well. And that is the solution to my inequality. Okay? What questions do we have right now? Now, if you took algebra, oh, go ahead.
Can you explain why the third one is negative?
Why this is negative? Is that what you're asking me? Okay. Because when I put in, what do we put in? 0. 0 minus 3 is negative, then positive, and then positive. So a negative times a positive is negative. Okay. Good question. Anything else? All right. So if you took algebra 3, y'all have already done some polynomial sketching, which you can do with sign charts as well. And there's different ways to do things, but you didn't do it that way. I would bet my life on that. But I want to show you what this tells me about a polynomial. First of all, you need to remember that polynomials look like they always have a domain of -infinity to infinity. So it's some sort of squiggly something, right? That's a polynomial, squiggly something. And so there's no discontinuities or anything. If this from -infinity to -4, my function is negative, that means it has to start down here. And then this is where I'm crossing the x-axis. So it starts down here, crosses the x-axis, becomes positive, has to turn around and become negative, has to turn around and become positive. And that's a little sketch of my function. Now, what I don't know, and I don't have enough, well, I have enough information. We don't have the skills or haven't talked about it yet, is what I don't have is the, I don't know where the maximums and minimums are. I don't even have a y-axis, right? But I do know where my function is positive and where my function is negative, and that tells me a lot, okay? Questions on that? We good? Okay, let's look at 5. All right, 5 is completely factored. Let's make our number line here. I only have 2 zeros to put on here, one at -2 and one at 5. And then this means that I want negative and 0. So that means these are closed circles. All right. And now I'm going to test points. So between -infinity and -2, I could pick -3. -3 plus 2 is negative, but I'm going to square it. So no matter what I put in here, the output's going to be positive, right? So that first one's going to give me a positive no matter what. I put -3 in here. -3 minus 5 is a negative number. So positive times negative is negative overall. Okay, everybody okay with that? Then between -2 and 5, what can I choose? 0. The first one's going to be positive no matter what. I don't even have to think about it. And then the second one's going to be negative. That makes it negative overall. Then 6 First one's going to be positive no matter what. 6 minus 5 is positive. That makes that positive. Now, notice these did not alternate. We'll talk about why in just a second, but they didn't. So now I'm going to get my answer out of this. It says we want it negative and 0. So here's my negatives, and I get to include the zeros, right? So even though this looks like two sections, because I get to include the 0, I'm going to start at negative infinity. I get to use all of this, the 0 and all of that. So I'm going all the way to 5, and I'm including 5 because it's closed. Okay. Everybody okay with that? Now let's pretend like, let's pretend like f for this one, we had f of x is just less than 0, that it wasn't less than or equal to. Then I would have to go from negative infinity to negative 2. And I'm not including negative 2. I have to jump over it, start back at negative 2, and go to 5. Okay. So I don't ever want to jump over them if it's closed, but this basically just means here I'm just leaving out negative 2, where here I got to include it, and that's why it's one big interval. We okay on those? Questions? All right, so look what happens when I draw this one. I'm going to start down here because this is negative. I come up, I have to hit this 0, it stays negative, and then it turns around and becomes positive. So remember yesterday when we talked about multiplicities, and when your function is tangent to the axis, that's when you have an even exponent. And that's what's happening at negative 2. It's tangent to that axis, and so it's bouncing off of it, and that's why we didn't alternate between the positive and negative. Okay, we okay with that? What questions do we have? Anything? All right. Now we are going to look at something that's going to look very familiar, almost like, hey, we already did this exact same thing, which sort of, but with a different explanation. And so we are going to determining the degree of a polynomial given a table of values, which we've already determined from a table of values if we have linear or quadratic, but this is going to go beyond that. If a given table of values with equal width input intervals, which is also the same as equal length input value intervals, we can determine the degree of a polynomial by determining successive differences in the output values. Okay, so we're looking at the differences in the output values. We're not technically looking at the rate of change, even though they kind of go hand in hand. All right, bless you. So the number of successive differences is the degree n of the polynomial. So we always start with our tables looking at the equal length, see if we have equal length input value intervals. I totally do, right? Those are all 2. Then, just like we did on the other tables, we are going to find our differences here. Now, you have to find them accurately, which means you have to be able to add and subtract positive and negative integers. Negative 3 minus a negative 2 is negative 1. Negative 1 minus a negative 3 is 2. 4 minus a negative 1 is 5. 12 minus 4 is 8. Okay, so we've looked at that as the rate of change. We've looked at that as a few different things, but we're going to consider this. This is our first differences. My first differences are not constant. If they were, because these are constant, I'd have a line, but I don't, right? So then I look at the next differences. 2 minus a negative 1 is 3. 5 minus 2 is 3. 8 minus 5 is 3. These are my second differences. We've already, like I said, we've already done this exact same thing. And we could answer this question by saying this function is quadratic because the average rates of change over consecutive equal length input value intervals are changing at a constant rate. But that's not what they're asking us for here. And the majority of these questions are going to be multiple choice for you. You're not going to have to determine how to write it. And if you are, it's going to be very clear, like these instructions. So we have to understand how to answer it a few different ways. It's just the way that it is. So what I would say here, because what it's asking me for is what is the degree? Okay. So I would say degree is 2 because, okay, because the second differences of f, we have to name him, second differences of f, and then I have to say over consecutive equal length input value intervals. Okay. So the second differences of f over consecutive equal length input value intervals are constant. I'm not so sure after reading some of those explanations on your test that some of you understand what constant means or change means or even rate of change means. I don't know. For some of you, I feel like you were just throwing words out there and hoping something would stick. I'm not real sure, but there's a difference between constant and changing at a constant rate. If something is changing at a constant rate, it's changing. So it's not constant. So you have to be very careful with what you're trying to say. Questions about this? Do you see how it's the same but different? We're still talking about a quadratic, but instead of looking at the rates of change, we're looking just at the second differences, which is kind of what we were doing anyway. But again, we have to know how to look at it a few different ways. We good? I'll take that as a yes. All right. So then let's look at this one. We look at our inputs. 3, 3, 3, 3. They're constant. That's good. Okay. 0 minus a negative 2 is 2. 10 minus 0 is 10. This gives me 17. This gives me 23. These are my first differences. Clearly, I need to look at my second differences. So I look at my second differences. 10 minus 2 is 8. This is 7. This is 6. Well, my second differences aren't constant. So I move on to my third. 7 minus 8, negative 1. 6 minus 7, negative 1. Those are the same. Okay? So if my third differences are constant, what's the degree? What are your epiphanies? Tell me. I have to know. Tell me. Somebody better tell me. Tell me. I'm gonna thump you with your. Tell me. Immature. Okay. All right. Sorry, I asked. All right. So the degree is what? 3. Okay. So degree is 3 because third differences, see how those match? Differences of G, and then I have to say over consecutive equal length input value intervals are what? No. Are they changing? They are constant. And you could go on to the 4th, 5th, 6th differences, and you get their 6th degree, whatever. But what questions do you have? Is that doable? So if it asks you to talk about the differences, that's how you have to change your words. Or just know when you're reading the multiple choice that there could be multiple ways that they address the topic. Okay, we good so far? Questions? All right. Now, on the other side, Even and odd functions. We have talked a lot about even and odd degrees. Even and odd degree is different than even and odd functions. Okay? I can have an even degreed function and it not be an even function. I know the terminology is very, very close, but I didn't make it up, so it is what it is, right? And really, you should have talked about these in Algebra 2 also, so it shouldn't be brand new, but even functions. So an even function visually is symmetric over the y-axis. We should understand our symmetry from geometry and from junior high and elementary school. But here is my y-axis, and you can see the reflexive symmetry right there, right? But we don't always get to look at the function. So the other part that we need to understand is that you have f of negative x equals f of x. Here's what that means. I'm going to pick this point right here. This point is 3, 2. 3, 2. This point here, and remember all of your points are x, f of x. Okay? My input is x, my output is f of x. So if my input is negative x, if I have a negative 3, well, f of negative x has to be the same thing as f of x, and it's 2. And that's why it's symmetric to the y-axis, and it reflects there, okay? You're just changing the side. That'll happen for every single point that you have, okay? We all okay with that? So let's write something up here. Add this in. There's a little bit of room to write. Right here. For every x, y, there is a negative x, y. Okay? That's what makes it an even function. Algebraically, it's very easy, but it's one of those things that y'all try to make way too hard most of the time, because you're really good at that. All right, so let's talk about odd. An odd function is symmetric about the origin. That is your rotational symmetry or point symmetry, with the origin being the center of rotation. If you were to take your paper and turn it upside down, your graph's going to look exactly the same. I can't do that with the board, but you could do that with your paper, and you'll see that they're exactly the same. Okay? That means that it's symmetric about the origin, not just rotational symmetry, but specifically point symmetry. And in this case, g of negative x equals negative g of x. So if I look at this point right here, let's see, we're going to pretend we have to fake these points just a little bit. We're going to pretend like that point is at 2, negative 2. All right. And then, so if I have g of negative x, so at negative 2 right here, so when I change the sign on x, I also have to change the sign on y, and it's to positive 2. Okay. So for even, you're only changing the sign on x. For odd, you're changing the sign on both. So to write up here, well, let's write for every xy, there is a negative x, negative y. Okay. Everybody with me so far? See how that works? Now, visually, I think y'all usually get it pretty good. The algebraic part, which is not difficult, but the work is your answer and it is your explanation. And in those kind of situations, sometimes that's what throws some of you off, because especially if you think you shouldn't have to show work and you can skip steps, because then you're not actually explaining anything. So let's just get through this and see what we're going to do here. If I have a graph, I know what to do. I can look at it. If I have an equation, I have to do a little bit of stuff. Now, this is an even degreed polynomial. That does not guarantee that it is an even function. Do we understand that? Like, it could be, and it's definitely not going to be an odd one, but it could be an even one, all right? And so we're going to substitute in a negative x, h of negative x. So my first step is 0 work. I substitute it in. It's going to be 2 times negative x to the 4th minus negative x squared plus 5. All I've done is substituted it, okay? Then this is h of negative x. So negative x to the fourth, is that going to be positive or negative? This part, positive. So this is going to be 2x to the fourth. And then negative x squared, this part becomes positive, but I still have that minus there. Minus x squared plus 5. Everybody understand what we did? We substituted in a negative x, cleaned it up. Okay, we good? All right, so then we look at this and ask ourselves, does it look exactly like the original? Yes or no? Yes, it does. So since it does, look, this is h of x, this is h of negative x, right? So I can say that h of negative x equals h of x. And since that is true, what is this, even or odd? Even. And this is an even function. Don't tell me it's an even degree. We know that. That is a true statement, but that's not what the question is asking. Okay? We good on that? So your explanation, this stuff right here, this is your explanation. You got to show that, even though, I mean, I know sometimes you can look at it and you'll know what's going to happen. That's great. You still have to show it as part of your proof. Okay? Questions? All right. So then over here, we're going to, so this one, this is an odd degree. So chances are pretty good it won't be an even function. It could be an odd function. So we're going to substitute in a negative x. K of negative x equals negative x cubed plus 3 times a negative x minus 1. Okay. Then we clean it up a little bit, right? So K of negative x equals, what's negative x cubed? Negative x cubed. Negative x cubed minus 3x minus 1. So then we ask ourselves, does this look exactly like this? The answer is no, which is not really a big shock because it wasn't even an even degree, but no, it's not the same. When that happens, then we factor out of this a negative 1. So this is still K of negative x. Now factor out that negative. That leaves me with x cubed plus 3x plus 1. Then I ask myself, does what's inside these parentheses look exactly like what I started with? No, it's pretty close, but this throws it off, right? So since it is not exactly the same, then K of negative x does not equal negative K of x, right? Because that's what that would have been. This would have been negative K of x. That would have made it odd. It's also not equal to K of x. So that's what makes it neither. If it was odd, what's inside these parentheses would look exactly like that. Okay. What questions do we have? We good? Do you have a question for me? Okay, I just saw you looking at something. I want to see if you, do I need to clarify something? All right, we good? All right, so then we've got our graphs here. Visually, it's a little bit easier, right? And this one, so clearly doesn't have y-axis symmetry. Does it have origin symmetry? Yeah, and if we kind of, you have to kind of pretend on that point a little bit too. This is 1, -3. This one would be -1, 3. So we're changing the sign on both, and that happens for every single point on there. Then we can say xy maps to, okay, maps to -x, -y. So that means that is an odd function. Everybody okay with that? So then here, if I pick this point is 3, 1. This point is negative 1, 1, but they are corresponding points, right? Does this graph have symmetry? Yeah, it has symmetry. It doesn't have the kind I want, but it has symmetry. The symmetry is right here. For it to be even or odd, it would have to have symmetry about the y-axis, right? So it doesn't have the symmetry I want. And not only can I tell it from that way, but this negative x, y, that they don't match, right? And so this is all fine and good, and we can just say neither. Okay. Don't necessarily have to explain much on those because they'd be more multiple choicey anyway. What questions do we have? Anything? Okay, awesome.